Alright, for number 3, we're looking for the range. So what are we looking for?
Y.
So y's. So if we're looking for the y's, and this is a continuous function, we need to look for our lowest point to our highest point. What is the lowest point of this graph? Negative 2. What is the highest point of this graph? It keeps going. We don't know. So because it has a stopping point or a starting point, and it's a continuous function, it's going to start off like this, bracket y line, every single time, depending on if it's domain or range. If it's a continuous function, it has a starting point, but it keeps going up. So this one's going to be everything greater than or equal to negative 2. If it had 2 stopping points or a starting and a stopping point, that would be the type where it's a number less than or equal to x or y less than or equal to that number. But if it only has 1, it's going to look like this every single time. Now, if the circle was open, it would just be greater than. You could also write this like this. As long as y is on the correct side of the inequality. So here, it's on the side that opens. It also needs to be on the side that opens. So make sure you have one of those written down. Make sure your name is written on your paper because those are new sheets, and pass those up. It will be.
Can I take a picture of it?
I'm going to say it out loud so you don't really need to.
Work. I want to write down work.
Yeah, I also want to work.
Okay. So for number 1, the answer was 7. 2 was negative 7.
Wait, I don't have that packet. Oh yeah, do you want to also take a picture if I don't have time to copy it all?
That's fine. I mean, I'm giving you time right now.
Have we done this before?
Evaluating, yes. You can come grab another one. Number 3 was 576. Number 4 was 33. Number 5 was negative 19. 6 was negative 28. 7 was negative 10. And 8 was 13. Do we have questions on any of these 8?
No, but hold on.
Yes.
How exactly do you do it?
The cube root. I'm going to show you here in 1 second.
Am I just going to submit it?
Yes.
How do you do the little brackets again?
I'm going to show you here in 1 second. Nathaniel?
I forget what the 3 above the square root means.
Cube root. The cube root.
Yeah.
I'm going to show you guys where on your calculator that is here in 1 second.
Okay. I got scratched that PE so many times.
How did you get
Does anyone else still need this? The slide gives me migraines, so I'm sorry.
Wait, what? I just
If you still need this, go back. On your calculator, if you go into math and hit the number 4, that's where your cube root is. You can't do the square root with a cube outside of it. It's not the same thing.
Yeah, because you get an error.
Right. So use number 4 for your cube root. You can also use number 5, but in order to use number 5, you need to put the number in first, and then go into math and hit 5, and it becomes a cube root.
So 3.
So you can either put in the number 3 and then go math 5, or just go to math 4. For your absolute value, I know there's 3 places you can find it, but I can only think of 2 right now. If you go into alpha window, at the top, ABS pops up. That's your absolute value signs. And then everything you always need is in your catalog, so that's above 0. The word is above 0. So if you go into your catalog, you'll find your absolute value signs there as well.
What are absolute value signs?
They keep whatever is inside, they turn it positive. It's really a distance. It measures distance.
And that's for like your little bracket things?
Yeah, but they're straight.
Yeah, that's what I mean. Oh, wow.
I'm just looking over it. You said it after. So.
For number 9, the answer was D. I know a lot of these phrases look very similar. The reason it's D and not like A is because the word's less than. Remember that anytime you get the words less than, whatever comes in front of those words, it'll be on Edmodo. You can stop taking pictures. Anytime you have the words less than, whatever comes in front will go to the back. But in A, it just says less 5, so that's the same thing as like subtracted by 5. Let me say number 2.
Is that one?
No, you're not.
I don't have my glasses. Is that one? What is 10 cents?
I'm about to read it.
No.
Josh. For number 10, 10 through 15, you should have been translating these into algebraic expressions or equations. So the square root of x all over 5. For 11, the cube root of x times y, and then minus 12.
So what are you going to teach us?
We did. This was like the first thing we did.
That's why I know.
I wasn't here.
Okay. For 12, the square root of 16 plus 4 times the cube root of 8. Now, I went a step further because these were all numbers. So the square root of 16 is 4. The cube root of 8 is 2. 2 times 4 is 8, and you can add them together. For number 13, you could have written this either way. 4 times the cube root of x equals 84. Or you could have used parentheses.
What is the exponent for 11? This is a cube root.
What is it? Like, what is actually
The cube root of x, y minus 12.
Well, what's that tiny number?
This is a cube root. It's not an exponent.
It's a 3.
Wait, how do you like solve square root or like?
You put it in your calculator.
Do you always use it?
No, but you'll figure out how to solve them in our next unit. Right now, just use your calculator.
Did you say 12 already?
Yes.
So, for number 10, I did something like a little different. It's a little bar line, like the
Use the division sign.
Yeah.
So, this is a really good question that you all need to hear. I said yes. If you instead put the division sign, because you are in high school now, you're no longer using that. So on the SOL, you won't see that. You need to be using the fraction bar.
Wait, why can't we?
Using the division sign.
Wait, why can't we use the division?
It's just gone in high school. I don't know why.
But will it just change the equation entirely?
This is still dividing. For number 14, I will go back after I read these two. For number 14, 16 over x plus 4 equals 9.
I played name again.
I don't know why some of you are talking. This is for you. For 15, you had to understand that if Amy is 4 years older than Jose, and their ages together add up to 100, you had to add the two together. So either one of these was fine.
I did 4x plus y equals.
So the variable could be different,
Okay, so it's still correct.
as long as it looks like one of these.
Is 4, then what is that next to it for the or? Like
2j,
J?
2j, 2j
So, and then what's before that?
plus.
So like
Brianna, go back to which one? She needs to go back to this page.
You know there's an equation that you can put on decimals and it makes a heart? But say something stupid.
For 16, if you did this one, your words could be different, and that's okay, as long as it is the same gist. So I wrote 5 times the cube root of the product of 4 and x subtracted by the square root of y. You could have changed those words, said maybe 5 times the cube root of 4 times x minus the square root of y. As long as you have something that looks like that or sounds like that,
I
it's
said
fine.
the 5 cube square root. That still makes sense. So I said 5 cube root square of 4 times x.
So you have to say that they're multiplied.
Okay.
Unless you say 5 of.
Okay.
For number 17, the sum of y and the cube root of x. Or you could have also said y plus the cube root of x. As long as you have something like that.
The sum of y and the
Cube root of x.
Was that for 16? Is that saying by the square root of y?
Yes.
That's easy.
Hmm?
The little pointer thing is
Oh, I was gonna say it's not doing that here, so I couldn't see what you were talking about. I don't know why that's doing it.
You go back.
For number 1, on the second section, number 1 was 16 over x to the 10th. Number 2 was 5y to the 15th over x to the 7th.
Oh my god, I should have
Three was 1 over x to the 5th, y to the 8th. 4 was 16 y to the 7th.
What is 2?
So what you getting?
What is 2's final answer?
2's final answer is 5y to the 15th over x to the 7th. Say to check Edmodo for the rest of the notes. Check Edmodo for the rest of the notes. Josh, that was unnecessary.
My bad. Come on.
4, 5, 25x to the 4th. 4, 6, y to the 3rd over 6x to the 4th. 4, 7, a to the 11th. 8 was D.
Oh, God. Yeah. Anybody have thought? You got a thought?
Yes.
I think I'm most of them right. I'm actually proud of myself.
Do we have any questions on 1 through 8?
Please don't move.
Alex.
I have a question on,
Michael, you're going to go back to your seat here in a second.
I got a question on number 1. Can you explain the process of how you do it?
Guys, Alex is right in front of me and I can't hear her because you guys are talking. Be quiet. Say that one more time.
Can you explain number 3, like, just how you got that answer?
So for number 3, you have to do what's in the parentheses first. Here, you're dividing. So if you're dividing my bases, you're subtracting. I feel like I did this one. Yes, I did.
Yeah, I got confused.
So let's redo. No one got that in the other department. So 3 minus -2. 4 minus -4. Is that the answer you had?
Yeah.
That's the answer you should have had. I just did it wrong the first time. D, as in dog.
Yeah, that's what I...
Alright, we're gonna switch gears. Take out your notes from last class.
Do we have homework?
Restore back this just cut out.
Turn it in. There were 4 problems you were working on your own. I want you to check your answers. Okay, I'll check that later.
You know young people can't
It's on that page.
Miss Burke, one more time.
This is the first page. The first page from back. Do we have any questions on 3 and 5? We did that one together.
When you look.
I do.
Check your answers for 7 and 8.
Wow.
Josh, are you checking your answers?
No, Miss Orr.
Do we have any questions on 7 and 8?
Yo, I don't Yo, is that this? Look, this is why.
Josh, do you have those?
The one I said.
They weren't given last class. They were given the class before, I think.
That's what I have.
No, this is not the one.
Yeah, it is.
But if you don't have it, Ryan, I have one extra.
Yo, I need it. I need the extra.
Way to get it first.
What? Are you
Josh, do you honestly not have it?
Yeah, I honestly feel like I don't have it.
Let me run a copy of this.
That's a 9 and an 8.
That's a 9. That's
How a guy was getting executed in Alabama.
Scroll down to. Scroll down. Find this on those in those notes. I don't know why I said that. So now we're doing polynomial operations. So we're gonna be adding and subtracting and multiplying polynomials. So remember that polynomials are just multiple terms together. So we're going to do one of each. So for this, for number 1, you need to understand that this is one of your polynomials and this is another, and we are adding these two together. But in order to add them together, we are just combining our like terms. So there is 2 ways to go about doing this. One of them is to put them on top of one another so that they're vertical. So I can move this polynomial down here. I'm adding and then bringing down each of these operations. So plus 7x minus 7. In this case, we are not doing anything with the exponents because our exponent rules don't apply to this, because we're not multiplying our bases or dividing our bases or raising our bases to another exponent. So if we're adding these two, 6x squared plus 2x squared is what? 8x squared. Negative 2x plus 7x.
Plus 5 minus 4.
And then minus 4. 3 minus 7. That would be your answer. It is.
I always do.
So in this case, we know we're done because we cannot combine any of these. None of these are like terms. One has an exponent, one has just a variable, one is a constant. They're not like terms. The other way you could go about doing this is to leave it in a horizontal line. If you were to do that, you have to look at what are your like terms. So I could say that 6x squared and 2x squared are like terms. Negative 2x and positive 7x are like terms. And 3 and negative 7 are like terms. And I could combine them that way. You would get the same thing as long as you combine them correctly. Questions on number 1? For number 2, we are subtracting. But because we're subtracting, we have to think back to when we were doing systems. When we were doing systems of equations by elimination. Because we have to subtract the entire equation. And that's what we're going to do here. So I'm going to move this down here. But we have to subtract the entire thing. So 3x squared minus 4x squared is negative 1x squared. 5x minus negative 7x. 12x because they become a plus.
What is the last number in parentheses?
Negative 9. Negative 6 minus negative 9. Positive 3. We can't combine any of these, so we are done.
I'm so confused.
On what? Pick a place that you're confused at. First step in all. The first step on which problem? Pick one.
Why are you looking? Pick what?
Just pick one.
Mama looking.
Oh, no, we're gonna do either one.
You look at me like, do you want me to pick your question?
So for number 2, the first thing we did was move it. Brianna, you're confused. I'm helping you. Brianna, we're subtracting. So I took this.
Why are we subtracting?
Because it says subtracting.
Oh,
And then we subtracted. That was it. This and this and this and this. Yes. The first problem, we just added them together.
Okay.
For number 6, how would we simplify that? For number 6, we would distribute. So 5x minus 20. Can we combine those two? No, so that would be our answer. Yes. Now, for number 7, it gets a little bit more complex only because we have a variable. We are still distributing. But because we are distributing, we are now multiplying like bases. So what are we doing with our exponents? We're adding them. So if we multiply negative 4x squared and x squared, what would that become?
Negative 4.
Yes. Negative 4x squared times x squared would be
negative 4x to the 4th.
Yo, I don't get any.
Negative 4x squared times x squared.
And then it's plus
Yes. That's how we got 4 as the exponent.
Screw it off on that. Yeah, now. I'm confident most of my all my guys.
Oh, then you do minus.
I haven't gotten that far.
Okay, never mind. Not
Negative 4x squared times negative 5x.
20x.
Positive 20x to what power? Third power. Negative 4x squared times negative 3. Positive 12 x to the second power.
only when I get is number 6.
Can we combine any of those?
Yeah.
Do they have the same exponent?
No.
No.
So you can't.
So you cannot. That's your answer.
That's
If they don't have the same exponent, we cannot combine them. Where did I get what? Negative 4 times negative 5. And then x squared times x. Let's do another one of these. For 9. Same thing. What is negative 3x times 6x to the third? 9.
Negative 18.
Negative 18
To the 4th power.
x to what power, Jay?
The 4th.
To the 4th. Negative 3x times negative x squared.
3x to the 3rd power.
Positive 3x to the third power. And the last one?
Negative 3x to the 2nd power.
No. It's to the first power because this one doesn't have an x.
Oh, yeah.
Can you combine any of those?
No.
No. So that's your final answer.
Wait, I'm a little confused. How? If we have 3 times 6, that's 18, and then never mind.
Okay. Jasmine, did you have a question?
Why'd you skip?
Because you're gonna do those.
Wait, what?
So you can
Which
ask
two?
questions. So I'm going to give you 10 minutes to do the other 5. If you have questions, I'll be walking around. You can ask. You guys want to
Dude, I'll pay for it.
I started.
What is this?
What
is this?
Try it. Try it. Try it.
I'm allergic to
What are you allergic
peanuts.
I don't think it has peanuts. It has caramel and chocolate. Let me check. It's like a Rolo.
Huh?
It's a Rolo.
No.
If you kill me, I'm suing you.
Wait, no. Don't try it. It has sunflower.
What's this?
Oh my god, you're killing me.
If it's not peanuts, it isn't that.
I don't know. Don't try it, because I'm not sure.
Let me see it.
Yeah, I'm not sure. Alright, eyes and ears up here. Check your 5 answers.
I'm gonna try it. I
Okay,
know.
just be careful because my mom is allergic to pork, so.
Alex.
Yeah.
Sorry. Thank you. Do we have any questions on these 5?
Bro, I'm actually smart.
Alright, so this multiplying we were doing was multiplying monomials, which means one term,
to polynomials, you may want to move Christina so you can see.
I can see better because like it's hard for me to see that. If we're not with glasses.
Just to say there's plenty of other open seats.
It's fine.
Now we're going to multiply binomials, which means two terms. So before I show you how to do that algebraically, I want to show you a different way to do this.
Oh, algebra tiles! Can I
Ladies, go back to your seats. Alright, so before we talk about how to do this a different way, we're going to be using algebra tiles. So you don't have them physically, but if you like this method, you would be drawing it. So for this, in order to do this, you need to know a couple things. Anything in red is a negative. So you have -1, -x squared. And then the colorful ones are the positives. +1, +x squared. How would we represent -2x squared?
two positive x squares?
-2x squared.
Just two of the
Oh,
red.
negative.
Two of the red. Which ones?
What the rectangle?
These?
Yeah.
It's gonna rain.
No, you use the -1. Use two negative x squares.
Wait, what even is the green one?
It's positive x.
Oh, I get it. Okay.
So what if I asked you to represent this? How would we do that?
3 x's, 3 positive x's, and then 5
positive
negative 1s.
x's, 5 -1s. Okay. What if I asked you to represent this?
Okay, 2 negative x squares, 1 negative x, and then a -1.
Alright? Now that we know how to represent them, now we're going to actually multiply our binomials. Binomials? It means two terms. Yes. How would we represent 3x plus 3?
3 positive x tiles, and then 3 positive 1s.
How would we represent -3x plus 1?
The exact same thing for the x, but negative. But you have one positive tile.
-x, 3 of them,
-3x
and 1.
and 1. I've been having this issue all day. It's fine.
So, oh,
Okay. And then, in order to do the next piece, we need to multiply each tile to each other tile. So what's -x times +x?
0.
No.
Because it cancels each other out.
You don't know.
Right. We're multiplying. When we multiply like bases, what are we doing with our exponents? Adding. So what is -x times x?
-1 times 1 is 2.
-x times +x.
It's unknown.
I didn't even say anything.
Nobody else said something about my AirPods.
So if you're not talking about this, you should not be talking. If we are multiplying like bases, what are we doing with the exponents? We're adding.
Zero.
We're adding. What is the exponent of x? 1. What is the exponent of -x?
-1.
Still just 1.
Wait, how's it?
What? Because even if you have a negative base, the exponent is still positive.
Oh, the F.
So -x times +x is
0. -x to the power 2.
-x squared.
Oh my god.
So the same thing would apply. Negative x times x is negative x squared. Negative x times x is negative x squared. What's negative x times 1? Negative 1x. And then we do the same thing for the next row. So negative x times x, negative x squared, negative x times x, again negative x squared, negative x times 1, still negative x, and we would do the same thing for this row.
Did you really hate that, Dara?
What's the homework?
Bro, Zara, what are you?
What? I feel like I don't.
It was
add it down, but I'm gonna forget.
You never gave us homework.
What is 1 times x?
Oh,
X. 1x. Yes, Michael.
We have homework.
What is 1 times x? 1x. I can't click these. Same thing here. What is 1 times 1?
1.
1. 2. No, just 1.
I feel like this, if we do this method, it's gonna like take a long time.
Try not to look at this. Actually, that's not your answer anyway. But here we have positive x's and negative x's. So in order to see how many we have total, we need to count up our negative x squared. How many do we have? 9. So negative 9x squared. In order to see how many x's we have, we need to pair the positive and negatives together. Which one is positive? Positive is green. So anytime we have a positive and a negative, they cancel. Think about that as negative 1, positive 1, they cancel.
We didn't have this thing on the test.
No, you would draw it yourself.
What? That's.
Yes. How much do we have left inside here? We know it's negative 9x squared. How many x's do we have?
9.
Negative 6. How many ones do we have? In here. So negative x squared minus 6x plus 3 would be the answer to multiplying these two together. We're going to do another one. How would we represent 3x plus 2?
3 positive x's and 1 positive 1's. 2 positive 1's.
2x minus 3.
I can't.
With this computer. So when you do it, it won't do this.
no, I don't know what you just said.
I said you scared me.
What is x times x?
X squared.
X squared. So it's positive. Same thing here, same thing here. X times 1.
1x.
1x.
Okay, stop.
Same thing would be for this column.
Oh my.
Negative 1 times x.
Negative x squared.
Negative 1x.
Oh.
You would have bounced the column. Yes, you would have. Yes, you would have.
Negative 1 times positive 1. Negative 1 times positive 1.
Negative 1 squared?
No. Negative 1 times positive 1.
0.
Stop.
Multiply.
It's not my pen.
X
Next
squared.
one.
It says negative 1.
What? No one else.
Yeah, we're not gonna tell you where it's at, so it's tiny.
That's like.
Oh, it candy does better.
Whoa.
So in this case, we have positives and negatives. So anytime we have positives and negatives, they cancel.
Are you gonna do this on paper also?
You would do this on paper if you like this method.
It's gonna take forever.
You would just draw it. Yes.
Why can't we just use the computer instead of like drawing it? Because I feel like that would take like.
Now, algebraically, these look like we're going to distribute, and we are. But we need to rearrange this a little bit. Because here we need to multiply x times everything and positive 5 times everything. So in order to do this, we're going to rewrite it as x times x plus 7. Josh, write this down. Plus 5 times x plus 7. Oh, Maddie. What is x times x?
X times x is 7x. Wait, no, is 1.
X squared. X times 7.
X 7x.
7x. 5 times x.
5x.
And 5 times 7.
30.
Wait. Oh wait. 35.
Can we combine any like terms?
Yes, we can.
Yes. Jay, stop talking. Ladies, stop talking. Yes, we can combine like terms. These two. So our final answer is this.
Yes, I was right. Never mind.
Well, never mind, because they're 4 now.
X squared plus 12x plus 35. Now, if you like distributing this way, that's fine. Another way you may distribute is by using these 4 letters.
Oil.
So we're going to use multiply our first 2 numbers. Guys, stop talking. Multiply our first 2. What's x times x?
X.
X squared. Multiply the outer 2.
36.
X
Oh.
times negative 6.
Negative 6x.
Negative 6x. Multiply the inner 2. 9x. And multiply the last 2.
Wouldn't that be 36?
Too much.
No. Oh, that's 4. Shoot. What am I blanking on? 54. My bad.
Negative 54. What would the final answer be?
X squared minus not 30. 30
Right, let's do one more of these.
if we're multiplying our first two, what's 5x times x?
5x.
5
X squared.
x squared. What's 5x times negative 4?
I got you.
What's the question?
Negative 20x.
Negative 20x. 2 times x.
2x.
Positive 2x. And 2 times negative 4.
8. Wait.
Negative 8. What would our final answer be?
5x squared.
Stupid pendejo.
Guys.
Minus
You should be paying attention.
Alright. What? Go to the bathroom. What?
I don't know her.
That thing cochina.
Okay. Now, at the bottom of this page, there are multiplying binomials to polynomials. So I just want to show you one of those. In these cases, you are multiplying, distributing just like you were before. So you're multiplying x to everything inside. Plus 2 to everything inside. Watch your mouth.
You don't smack.
You guys' test is next class.
What?
Yeah.
Whoa.
Hold on there.
Wait, is this a test? This is easy, but the other simplified shit is.
So as you guys have been playing this entire period, when you don't have this information, that's why.
But we're just learning this. How are we going to take a test on it?
What is x times x squared?
X
X
squared.
squared. X times 3x. You're adding your
3x. What?
X
4x. 4x.
times 4.
3x squared.
Oh, squared. When you're multiplying like bases, you're doing what with your exponent?
You're making it a squared. An exponent. I don't know. I give up.
You're adding.
What? How did I?
2 times x squared.
2x squared. Oh my god, I got that right.
2 times 3x.
6 squared.
6x.
Or 6x, yeah.
Just 6x.
And then
2 times
8.
4 is 8. Can we combine anything with this?
Yes, all of those except for the 8.
The 3x
And the cube.
squared,
Shut up.
and the 2x squared, the 4x, and the 6x. So when you get something like this, you need to put it in order. Highest exponent goes first.
So we add or multiply.
You would add in this case. So 5x squared plus 10x plus 8.
I'm totally not gonna remember that.
You do it, guys.
We. More like you can do it.
Bro, I'll see all my teachers next year, bro. You said it. Who was that?
There is one last thing I want to show you really briefly.
Oh, you totally have homework.
We haven't. It's next week. Next week is our last week. Your teacher.
Alright, listen.
My teacher.
So I'm making up this problem. You don't really need to write this down. For the last little bit of class, if you want to work on your review or have it so that you have it over the weekend, you will have that. On the polynomial operations piece, there are some that look like this. And they ask you to find either the area or the perimeter. How do we find the area of a rectangle?
Adding on.
Length times width times.
Just length times width.
That's all that's length times width. So if we're doing length times width of a rectangle, you're taking this and multiplying it to this.
I'm hearing a whole bunch of shapes and numbers and
If you would be quiet, you might hear a little bit more.
I'm sorry, but either way, I don't understand.
So in this case, if you have area, you're multiplying those two together. Simplify it, get your answer. Just like we just did. But if it asks you to find perimeter, how do you find perimeter?
You add them together.
You add your sides together, yes. But because they're only going to give you 2 of the sides, you need to remember to add them up twice or to use this. Okay? Now you only have about 10 minutes left of class, but if you would like the review, you don't need to work on it over the weekend, but I would suggest that. I will also say, I'm not saying after Monday because I have a meeting. So you'll have to come see me before school Monday or before school Tuesday if you have questions. You will need to do your Khan Academy because those are good practice for the tests. And then if you are doing this over the weekend and you do have questions, you can message me and I can help you. If you would like this review so that you can at least look at it over the weekend, raise your hand and I'll bring it around to you.
Oh, screw it.